Okay, we should be live now. And let me check the stream manager in Twitch. That's not loading. Why? It says excellent connection, but why it doesn't show anything? Okay, let's see restream IO. Okay. Yep. That's good. Okay. Yeah, so this is just documenting my basic electronics journey. I don't know much about the electronics part. I'm just learning the things we have, like, the capacitor, transistor and stuff like that. I'm just learning what are they and how it works, just that. Parallelly, I'm also trying to create something like this, which is kind of powered by a 1.5 AA battery, which just simply blinks an LED, but based on what I have seen in internet, it's called a Astable Multivibrator, which which has two transistors, which toggling on and off, and that kind of gives an effect of LED blinking or anything that we can build on top of that. I'm just doing an LED blinking on top of that. So this is just me documenting my journey, for me to in future to see how I did when I was learning this. That's it. So yeah, so that's about it. I also built I've seen a lot of simulators. One of them is this one. It lets you draw the circuit, I think that's how it pronounced, circuit, and it will help you simulate how it looks and all. Not how it looks, how it will be working, how the current flows, and stuff like that. It also gives you a view of I'm not exactly sure what these things are called, but it will give you this kind of view that what's happening in your circuit and what's happening on each element, how much voltage they are consuming, those sort of things. Again, I'm not exactly sure at this point how they work, like end to end. I just know, okay, there will be spikes that those are consuming the power, stuff like that. I'm not excited. I don't even know how to explain this. But yeah, this is me just trying to learn. Before going into this, I need to get to this. Yeah, so this is the same circuit I have built here. It's just a simulation of that. For some reason, the LED blink, this is an LED, so the LED doesn't blink as just like in the real world. So I had to build a tiny simulator for that. So this tool is basically simulates how much delay between each LED blink based on the params you give. So C1, C2 are the what is it called, capacitors, and R1, R2, R3, R4 are the resistors. So when I change certain resistors, I can see that, okay, that can increase the delay or decrease the delay. I can also change the capacitance and then the impact on the delay. And I'm trying to build a firefly effect which blinks every 5 seconds or something like that, and I will build like 5 of them and put it somewhere outside and see how it works, how it looks. Just that's it. So the to do for today is I have V1 and V2. This is the first thing I built. It looks super ugly, but it works. So the first thing is to add an LDR to that. The LDR, I think it's called light dependent resistor or something like that. I think it's light dependent resistor. Yeah, basically set the resistance, and I'll show you that component. These components are pretty new to me. This is my electronics box. Yeah, so I should now put it there. That's an LDR. So this will produce high resistance when there is no light. So if it's super dark, it's going to produce around 1 mega resistance. Otherwise, it's the opposite. And we can use this to only blink the LED during night time. For example, if I cut now this LED, I'm not sure if it's able to see this. At this point, this is not blinking because there are light around this thing. So if I cover this, it will start blinking. So I'm just trying to save some energy during daytime. So that's why I'm adding LDR. So the first step is to add the LDR to V1. So when I built V1, I didn't know there was such thing as LDR. And now I know, and now I need to add this. So that's what I'm going to do now. And this thing currently blinks at around blinks at every 1 second, I guess. Let's just let me fix my monitor. There is some short happening somewhere. Yeah, fine. Yeah, so so this one is 1000, yes, and the other one is 22, and the R2 is 100k, and what else? The other two resistors are 1k. Yes, and yes, this is blinking at a rate of 976 ms, almost a second. Now if I need to change, okay, two things. First, I need to add an LDR. Second, I need to increase the delay to 5 seconds. Now I'll do this thing first. Okay. Oh, before this, let me tweet that we are live. Let me tweet this. twitch.tv/TV. Okay. Tweet is sent. No. Cool. So let's. Okay, let me add this too. I had one to do sections, right? To do store.txt flag. Yeah. Can I add this in here? Yes. And let's add a work in progress emoji here. Yep. And that should reflect on the right side now. Will it work? Yeah, I don't think we need square faces and all. Less padding. Yeah, that should do it. That should do it. That's fine. Now the first task is increase the delay. For that we need to change the resistor from 100k to around wait, 750. No, I'll go about 430. Do I have a 430? Okay, we have a 5. Okay, what will be that number? This must be 510. Okay, we have a 510. With 510 we will get 4.9, and I think that's fine. Let's get this. So with 510 we will get this. With 510 we'll get 4.9, and that's fine. Yeah, let's do that. Let's get the yeah, we need to remove this. This component needs to be replaced. I think this is going to be a mess. Be prepared. This is definitely going to be a mess. Yep. Yep. What's the resistance of this thing? Wait. Brown, black, red. Resistance calculator. Brown, black, red, gold. What is this? It's 1K. And yeah, it's fine. Is it hot now? It's hot. How do I get this? How do I get this? Oops. I think I dropped another component which I shouldn't have. I think I should have cut this, not like this shoulder it. Okay, so the 22 resistor, part of me already regret doing this. Let's see. Okay, and this must be 100, right? This must be 100. Gee. This must be 100. Yeah, that's 100. And now we need to figure out another thing. How do I zoom out to this portion? Is there a scroll controller? No, right? No. So I need to zoom out, then zoom in. Okay. And this resistor 22, I should connect this to the positive side should be connected to the base of the NPN transistor. Okay, let's do that. Positive side to the base. Before that I should maybe we need to get one more thing in here. Yeah, maybe this will be able to help us. Maybe, but I don't have any hope. Let's try. me see if I can put this on this, and somehow I'm pretty sure I'm doing it the wrong way, but anyway. What the hell, this broke? How do I... Yeah. No, it's completely broke. And previously it was like about to break, and I tried to fix it and I broke it. How about now? Still not good. Let's try one more time. And how about like this? Fine. No. Let me try again. From all the angles, maybe. Yeah. We can just live with this now for now. Okay. So this won't work. What we can do is we can put this down here. Yeah, you can be able to hold it like this, and then yeah. Yeah, that should do it. Yep, that should do it. Shit. Yeah, think yep, strong. Now the other end of this should go to the collector of the NPN. Yep, the collector. Yep. And where is the collector? Ah, it broke again. I think the solder has to be a little more stronger than this. Yep, let's do that. Yeah. think what we can do is we can do a tiny bend like this, and then I think we can easily solder it. That should do it. Okay. Very precise. Building software is way more easier. Finally. Okay. Part 1. I think it's almost done. And second part, I need to connect this to the collector of the PNP transistor collector. Okay. Okay, let's go try that. No. Camera, I think it can come over here. Okay, we have to solder this part. It already has a ton of solder in it, so it should be okay. Okay, resistor is in place, strong, fine. Now we need our, what was the resistance that we are looking for? 510. Let's get this done. And the other other end of this resistor, one end should go to the base of this one. One end should go in. One end should go to the base of the NPN, and then the other end will go to the emitter. So this will go in here, and then it should go to that area. Fine. So we have to make a little bend over here before doing this. Yep. Oh no. Where should I put this to get locked? The base. Okay. I don't want this. That looks good. Did I burn the transistor? No, right? No. I hope not. Yeah. And if I connect this part to here, this should start blinking every 5 seconds. But it's not doing that. We'll figure out. Wait, let's. It's blinking. It is blinking. Let's verify the time it takes though. It's more than 5 seconds. So one end go to the base of this, the other end goes to the emitter, right? And the emitter is that, yes. Is there a short connection? No. It's blinking. It's just that the connection is not that strong. So let's make that strong. Okay. Okay. Yeah, it's blinking. Now let's get the actual time. Stopwatch. Okay. Go. One, 2, 4. Yeah, it's doing 5.5. It's doing 5.5, which is okay. We can leave it that. Wait, we need to add LDR also now, right? Yep. So the first part is done. Okay. First part is done. We did this. Now we need to add an LDR. Let's do that. Okay. There is some issue with the tool. That's not an issue for us for now. We need to add an LDR. Let's put this 100K back to my little storage box. What happened? Okay. Now where is the LDR? There you go. And where should I place this? The LDR should be placed let's update it on the simulator first and see what happens. So that's a transistor. I think it should be P. Yeah, oh, that's a PNP transistor. How do I add a photoresistor? There is a photoresistor. Yep, there is a shortcut. And photoresistor doesn't have a polarity, right? doesn't have, I guess. No, it doesn't have. Now let's look at this part here. Let's see. Oh wait, we have one sample already. Yeah, we have. So one should go to the base of the NPN resistor and other should go to the collector or the negative part, negative junction. One for the base. Let's do the base first. Where is it? Yep. Let's do the base. Okay. So before we do that, let's bend this side. Yep, that should do it. That's cute. No. I might break the transistor now. Let's do one thing. Let's take some and then see if that works or not. No. Ooh. No way. Okay, that was easy. So if I hold it, I think then it becomes a little easier. Okay, that looks like it worked. So I have to hold and now I have to put this into the negative junction. Shit. But yeah, I think I did it the wrong way, but that's fine. Part of the deal. I can only make mistakes now. Okay, I think we have a good connection. Okay. Did it work? Only time will tell. We'll see. Did it work? So if I... Okay. It shouldn't blink now. I'll wait for like 5, 6. Oh shit, it blinks, it didn't work. Come on. The connection is not that strong. It's a connection issue. Let's see. Yeah. No. No way. No. No way. Shit. I did another mistake. Shit. Okay. Okay. I think I have good connection. Okay, that's in place, this is in place. Okay, now this shouldn't blink. It did blink. So the base is connected, right? Yes. Wait. Maybe it's working because the light is on the other side. Wait. So if I do this, it shouldn't blink. I think it's working well. It's not blinking. So 1, 2, 3, 4, 5. Oh, there is still light. I need to cover something. Okay, if I cover this 1, 2, 3, 4, 5. Yes, it works. Okay, now with this it shouldn't blink. 2, 3, 4, 5. Cool, did it. That's also working fine. I have one question. What is the other one? Yes. Does this blink when it's placed to the other side? No, right? It doesn't. It's probably because the resistance of this thing is only 100, and whereas this one is 510 or something. So that's probably why. Okay, so that put us in a safe spot. We have added an LDR to the first version. Now the V2, this guy goes safe home, and for some time we'll just keep it under test. For that we'll just place it on top of this, and that should do it. Okay, it's blinking. Let's also verify the blink duration. Okay, and we'll use our stopwatch. Okay. Start. One, two, three. Oh, that's now around 6 seconds. So next time let's reduce the resistance down a little bit. So with this config, what happened is that rather than 4.9 we are getting 6. That's like 1.1 second difference. Wait a second, is that a 10 or 22? That's a 22. That's a 22. And the 22 on this is 50 volt and this is 63. That's probably why we don't have like less accuracy on this. But still, that's okay. Now, what if I reduce this to 10? This will be reduced to 2.5, which is not good. 22 is fine. 22 should be fine. Yeah, it's okay. Next time we do this, we will reduce this number to... Wait, we can... With an LDR it actually increased. We didn't take the LDR resistance there. We have to take the LDR resistance too in there. Okay, let's work on this one. Increase delay to 5 seconds. Okay, what's the current delay of this thing? And how do I get to know that? We can get that by placing this thing here. And where is our stopwatch? Oh, let's unplug this. Reset. Okay. Wait. Light is still passing. Okay. 1, 2, 3, 4. That's around a second. That's 1 second. We need to push this to 5. And the way we do is this is going to be tough because we have to remove that 100k from here. First of all, let's do one thing. Let's remove it from the power. Which side should I remove? I'll get the negative side. Okay, cool. Can I zoom into this section? Let me check that.
I can zoom. Slowly but surely. Does that make it better?
Okay, where are the borders?
The borders are here
And then, yep, until this point.
Yep.
Cool. Just So let's measure the delay first. So this is 1000 C1 and this is 22, correct? And this is 100K, and we are talking around 976, which is true. And yep, and if we push this to 5, 10, 430, yeah, somewhere around that range we will do. Okay. Okay. No way. I think it's not hot enough. Okay. Is it hot enough now? Should be. Still not hot enough. Push it back. She. I shouldn't have trimmed the resistor this much. No, that's not happening. I think it's not hot enough. I think it's hot enough. Is there anything I can do, Wayne? Oh, finally. Got it. So that's 100K. Okay. Now we need something around the range of 400 to 500. Okay. We have no 100. 530 we have. It's okay. Okay, we have a 460, I guess. Let's try with this. Before soldering it, let me double check the resistance. 470. Okay, this is just 470. We need 470k. Ah, stupid me. That goes in here. Okay. If it was software, it was more like, adding implementation, Gradle or something, and we have our dependency ready. 100, 2.1, 31, 461k, 0.9, again, 10k, no. We don't have any big numbers like that. 6, maybe just 6. 516, no. 2.2, no. No. Hey Arjun, what you're doing? I'm just learning basic electronics. That's it. And on the way building a LED blinker. Yeah. It's a very small thing, but it may look like I'm doing some rocket science or something. But I'm doing a very basic thing. To me, it's not a basic thing at this point because I'm just trying to learn. But yes. What about you? What are you doing now? 73. Which language you are using? There is no programming involved at this point. It's mostly just creating circuits like this. Circuits. I think that's how we pronounce. Yeah, something like this. And that's it. Without using a programming language. I'm searching for a 400k resistor if there is any. I don't think I have. I will have to move with the 513. Yes, we'll have to move with this. Currently developing time sensitive split trap. What do you mean by time sensitive? Okay, so we have to place this between this and the other end should go inward. Yeah, the other end should go in here. So what we need is, yep, something like that. I think I should get some shoulder. Yeah. Okay. That was too much. Okay, so yeah. Let's try this again. No. No. I guess it worked. And now let's finish this side. It's a game where time is precious, like betting at a perfect time you can earn gift cards, multiple timers with refreshing in background. Interesting. It's more like a multiplayer app. It's a game or something else. should work. Let's see. The connection is not that strong, I suppose. I think it's strong enough. I think this is enough. Let's cut this down. Okay. Let me see if it works first. So it shouldn't blink now. And let's say if I place any dark object on top of this, it should blink every 5 seconds. 1, 2, 3, 4, 5. It's not happening. Multiple messages and maintaining sync with server. Amusement betting game. Nice. So 100k that is going from the base of the NPN to the emitter of that thing. That should be fine. Now why it's not working is something that I need to find. Is it blinking? No, it's not. It's not blinking. Why it's not blinking is the second question we need to answer. Let's find that. Is the connection is client project which goes against my morals. I can't relate. But technically it's a good project, right? I mean, okay, is this working now? Is this working now? Yeah, it is. It is blinking. So we'll just verify it with some. Verify it with some what? Let's do this. So if I cover this, okay, if I cover this, okay, it should blink every 5 seconds. 1, 2, 3, one more, 4. Okay, yes, 5.2, which is good. So our math is working. Cool. Technically challenging as a desktop app and Flutter single-threaded implementation. Want myself to make it Kotlin JVM desktop. So is this your first project as in Flutter, Arjun? I think you were doing like native Android, right, before? Okay, we have a working circuit. How do I pronounce that? Pronunciation. Circuit. British.
Circuit.
Okay, that's a win for us. Second, this thing is also done. Now we need to make a new build. Okay, and let's try do that. So for this, let's remove this. For this we need new components. What all we need, we need a what? Let me change the music. Not developed around 20 projects done in Flutter, but not desktop app. But I have used Tonal FX with Kotlin previously, which is similar to Compose Desktop, but Java FX alternative at that time. I see. Understood. Okay, we need 1,000. How do I pronounce the? Okay, wait. Perplexity. How do I should paste this one? How do I? That's fine. That's a microfarad. Mu. It's not a U, it's a mu. But UF is often used instead of where the Greek letter is available. Understood. Microfarad. Okay, we need 1,000. We need a 22. We do not have a 22, I guess. That's my wife. Let me take that call. That's my wife's. Wanted to share some gossip. So what do you do about JavaFX or Compose for desktop? I haven't tried JavaFX. I use Compose Desktop when there is a desktop need. Yeah, I use Compose for almost everything now these days. I guess yes, I am using that for web apps, desktop apps, Android apps. It works. Don't have to learn a new construct. And that's an advantage. Okay, we need 1,000. We need a. What we have? We have a. This is 10. Think. Do we have a 20? No, right? We do not have a 20. How much is this? This is 47. What happens if I set this to 47? This will become 8.9. How about 10? And then can I increase this? And I'll need even if I have a 1 mega, I can only achieve 2.2, which is bad. Okay. So if I do 40 watt, 47, and if I do somewhere around I will need a 270 or 300. Do I have a 300k resistor? Do I have? I don't think I have 300, but let me see. 300k, right? Yep. Is there any possibility to direct use C library like for printer and printing them? I don't understand that question, Arjun. You are asking if there is any way we can use a C library from Java or Compose, Kotlin. $6.7k, 3.2k. No. Nope. How much is this? This is 100k. We have 1M. Oh, wait. No. Nope. 3.2, 9.1, 516. We do not have a 300k one. What do we do? We have 132k. In Kotlin Compose can interoperable with C library. So I'm not sure, but it should work. There's the system.load library. System.load library is not an Android thing, right? Or is it? It's a Java class, right? Yeah, runtime.load library. Yeah, we should be able to call this, and just like how we use the, I'm not exactly sure, I haven't tried this, but I would try do this first. What is the learning curve for interoperability with this C library? I'm not sure, bro. I haven't tried that. Should be easy, I guess. Shouldn't be much of a new thing. You probably will need to create an interface where you can, call the C functions from a Java env. But yeah, shouldn't be a problem. I would expect that to be easy. Easy. 2.1. We don't have the resistors we need. Okay, so let's do this way. If I have a 1M transistor, how much should I? Okay, a 22. Wait, how about a 10? No. What are the other resistor values I have? This is a 2200. That shouldn't change. That's fine. How much is this? It's 22. Yeah, we have 122. This is 22, right? Just double check. Yep, 22. 22 and 1M will give that 22 and a 510 will give 4.9. Yeah. Are you saying about JNI? Yes. Yes. I haven't done that in the JVM app. I have only tried that in Android, but that should work in JVM as well, I guess. Okay, so we have 1000. We have a 22. Fine. We have a 22, and then we need a 22 resistor also. Let's find that. I need a organizer for this. This is 1M. Where is 22? Okay. What is red, black, black? Oh, that's possible. Flutter, but need to generate all bindings using JNI generator. Yeah. We will pass it on a resistance calculator. Fine. And this will be red, black, black, gold. And this is a 20 ohms. Okay. That shouldn't be a problem. That shouldn't be much of a problem here, right? That shouldn't be. Let's check what happens if I put 20. Wait a second. Oh, I can't change this, but that's fine. 20, 22, it's fine. Shouldn't be much of an issue. Now I need two 1K. Yep. I have plenty of 1K resistors, but it's still very hard to find. This 100. This is 1K. Yep. Go. Kotlin versus Dart language performance, which is good or both? I'm not sure about that. I haven't seen any performance comparison between Kotlin and Dart. Check with Perplexity. Like technically, which one would be faster? 2, 1. Now I need one more resistor, which is the notorious 510. Where is our 510? Yep. We haven't plugged that yet, right? We haven't. Yep. So 510 goes in here. Okay. Now what else? We have two 1K, and then yes. Now we have 4 resistors. Yes, 4 resistors. We need one 3904 and 3906. This should be 3904. Yep. And 3906. This is 300. Yep. And that's it. We need a battery. We need a AA battery also. Yep. There you go. There you go. What else do we need? An LED, yes. As usual, we'll go with yellow. Okay. Yellow we have. What else? What else do we need? That's it. That's it. That's it, I guess. Yep. Yeah, that's about it. Let's go. Now, where is that thing? Okay. Now the 3904. This is 3906. This is the 3904. Yep. Let's do this and this. Should I try that new board? Should I try this? Let's try with this for a change. Let's see. I'll give some gaps. Should I? No, I shouldn't. I almost broke the leg. Let's see if we can fix that. I can. Okay, so a little more maybe. Yep. assume that's 3904. Yes. Okay. And we can't go all the way down. Should be right. Yeah, we can. Okay. Okay. That looks better. Now we need one more, which should be go somewhere around here. Yeah. I think we have to keep some distance from here to here. There are a ton of elements in between that. Yeah. Oh, wait. It should be here. Okay. Now, this is very scary. This is not good. Not sure what I'm doing with this. Okay, now the 1000, where should I place this? Think the leg just spread to. Okay, the good position for this will be near the. Yeah. Or should I just put everything at one side? No, it's fine. Okay. there is a problem. I should take a break. How do I take a stream timer? Yes. Where is the stream timer? Okay. And the break time will be 10 minutes. BRB in. Yep. And I can start this. And then I go to OBS. And then I can show the content timer. And that's how it works. No. That's not how it works. Countdown 3. This is break. Okay, wait. So let me. Yep, break.txt. Yep. And that should be on top of everything. Yep. And that should be at the center. Order. No, not order. Position. Where is position? Not order. No. Where is the position? I don't think there is a position available, but just I'll just put it here. That's it. Yep, that's a BRB. Yeah, few new things came in, so I'm stopping the stream now. I'll see you sometime later. Thanks to whoever tuned in.